Hi guys, today our group will presenting about infrared radiation technology. First of all, infrared radiation is a type of electromagnetic radiation that lies between visible light and microwave in the electromagnetic spectrum. Although it cannot be seen by a human eye, it can be detected as heat emitter object. Every object with a temperature above absolute zero emits infrared radiation, making it an important tool for temperature measurement and thermal detection. Infrared technology has become an essential part of modern society. It is widely used in healthcare for a fever screening, in security system for night vision surveillance, in industry for equipment monitoring, and in everyday devices such as smartphone and remote control. Its ability to detect heat without physical contact make it highly efficient, safe and reliable. Next, there are 5 significance of infrared technology. First, allow temperature measurement without physical contact. Second, improve safety in industry environment. The third one is enable night vision and surveillance system. The number 4 is assist in medical diagnosis and health monitoring. The last one is support automation and smart technologies. There are 4 important instrument systems in infrared radiation technology. Number 1 is infrared source. The object being observed emits infrared radiation in the form of heat energy. Number 2 is infrared detector. The detector sense of the infrared radiation and convert it into electrical signals. Number 3 is signal processing unit. The electrical signal are amplified, filtered and processed to obtain accurate information. The last one is display unit. The processed information is displayed as temperature readings, graph or thermal image. There are 5 importance of infrared radiation in scientific instrumentation. First, sensing and detection. Number 2, signal and conversion. Number 3, data processing. Number 4, real-time monitoring. And number 5, non-contact measurement.
Next, I will explain how infrared radiation technology works. Every object with temperature above absolute zero emits infrared radiation, which is a form of heat energy. Infrared cameras detect the heat and convert it into thermal images, known as thermograms. Different temperatures appear as different colors, making it easy to identify hot and cold areas. Since infrared cameras detect heat rather than visible light, they can work effectively even in complete darkness. One important application of infrared technology is industrial inspection and predictive maintenance. Thermal cameras are used to inspect electrical equipment such as transformers, motors, and switchboards. Areas with abnormal temperatures, known as hotspots, can indicate problems like loose electrical connections or overloaded circuits. By detecting these issues early, companies can perform maintenance before a serious failure occurs. Because the inspection is non-contact, equipment can continue operating while being monitored. Power utility companies commonly use this technology to improve reliability and safety.
Infrared technology is also widely used in healthcare and environmental monitoring. In medicine, thermal cameras can measure skin temperature patterns and help identify inflammation or abnormal blood flow. The technique is non-invasive and does not use harmful radiation. In environmental application, infrared sensors are used to detect gases and monitoring air quality. These systems help researchers and environmental agencies track pollution levels and protect public health.
Potential benefit of infrared radiation technology. Infrared radiation technology offers many advantages in everyday, even life and industry. One major benefit is non-contact temperature measurement. which allows temperature to be detected without touching the object. This makes the process more safe and more efficient, especially when dealing with hot surface, hazardous material, or moving machinery. By measuring temperature from a distance, workers can avoid unnecessary risks while still obtaining accurate results. Another important benefit is that infrared device can work in darkness and low light conditions. Unlike normal cameras that depend on visible light, infrared systems detect heat emitted by objects. This allows them to produce image even at night. As a result, infrared technology is widely used in security systems, military operation, wildlife observation, and search and rescue mission. It helps improve visibility and provide important information when normal vision is limited. Infrared technology is also useful for the early detection of equipment faults. In industry, thermal cameras can identify abnormal heat patterns in electrical systems, motors, and mechanical equipment. Overheating components can be detected before they fail completely, allowing maintenance to be carried out earlier. This reduces downtime, lowers repair costs, and improves workplace safety. Furthermore, infrared technology improves safety and efficiency in many sectors. Workers can inspect equipment without direct contact, reducing exposure to dangerous conditions. It also widely used in medical diagnosis and environmental monitoring. For example, thermal imaging can help identify inflammation in the human body and monitor temperature change in the environment. Therefore, infrared radiation technology provides significant benefit in both industrial and everyday application. Challenge and possible solution. Despite its advantages, infrared technology also faces several challenges. One of the main challenges is the high cost of equipment. Advanced thermal cameras and infrared sensors often require sophisticated components, making them expensive to purchase and maintain. This can limit their use, especially for small organizations or individuals with limited budget. Another challenge is that measurement accuracy can be affected by environmental conditions. Factors such as rain, fog, dust, smoke, and reflective surface may interfere with infrared readings. As a result, the data collected may not always represent the actual temperature of an object. This limitation means that users must carefully consider environmental conditions when conducting infrared measurement. In addition, trained operators are often needed to analyze thermal image correctly. Thermal image can sometimes be complex, and incorrect interpretation may lead to inaccurate conclusions. Without proper knowledge and experience, users may misidentify normal temperature variation as fault or overlook actual problems. Infrared technology also has a limited ability to detect objects behind obstacles. Since infrared radiation cannot easily penetrate many solid material, objects hidden behind barriers may not be detected effectively. This restricts certain applications where visibility through obstacles is required. However, this challenge can be overcome in several ways. Manufacturers can develop more affordable infrared devices to reduce costs and increase accessibility. Regular calibration and maintenance can improve measurement accuracy and ensure reliable performance. Proper training programs also can help operators interpret thermal image more effectively and reduce error. Furthermore, the infrared technology can be combined with other technologies such as X-ray or radar systems to improve overall performance and overcome some of its limitations. Through continuous research and development, many of these challenges can be reduced in the future. Future development and innovation. Infrared radiation technology continues to evolve with new innovation and technological advancement. One important development is the integration of artificial intelligence or AI into thermal imaging system. AI can analyze thermal image automatically, identify unusual patterns, and detect abnormalities more efficiently than traditional methods. This can improve accuracy, reduce human error, and save time in various applications. Another promising development is the use of smart infrared sensors in Internet of Things or IoT systems. These sensors can continuously monitor temperature and send real-time information to users through connected devices. This allows faster responses to potential problems and improve decision-making in industry, healthcare, facilities, and smart building. Thermal cameras are also becoming smaller, lighter, and more affordable. In the past, thermal imaging equipment was often bulky and expensive. Today, advancements in technology have made these devices more portable and accessible. As cost continues to decrease, infrared technology is expected to become more widely available to business and consumers. In healthcare, advanced infrared imaging may support medical diagnosis and pattern monitoring. Thermal imaging can help detect temperature change associated with certain medical conditions, allowing healthcare professionals to gather additional information without invasive procedure. Another important innovation is the use of infrared-equipped drones. These drones can inspect power lines, buildings, pipelines, and other infrastructure from a safe distance. They are especially useful in dangerous or difficult to reach locations where human access may be risky. As technology continues to improve, infrared systems are expected to become smarter, more accurate, and more widely used across different sectors. Conclusion. For conclusion, infrared radiation technologies has become an important part of modern technology. It provides many benefits including improved safety, efficient monitoring, accurate temperature detection, and early fault identification of various applications. These advantages have made infrared technology valuable in many fields and contribute to its widespread use around the world. Infrared technology is widely used in healthcare, industry, security, and environmental monitoring. In healthcare, it assists with thermal imaging and patient assessment. In industry, it helps and identify equipment problem before failures occurs. In security application, it improves visibility in dark environment and support surveillance activities. This example demonstrate that versatility and importance of infrared technology in everyday life. Although there are several challenges such as high equipment costs, environmental limitations, and the need for trained operators, continuous research and innovation are helping to address these issues. Improvement in device design, software capabilities, and integration with other technologies are making infrared systems more effective and accessible. Looking ahead, the future of infrared technology appears very promising. Advancements such as artificial intelligence and smart sensors and drone-based applications are expanding its capabilities and creating new opportunities. As technology continues to develop, infrared radiation is expected to play an even greater role in scientific research, industrial operation, healthcare service, and public safety. Therefore, infrared radiation technology will remain an important tool for innovation and problem solving in the future. Thank you.